Hi, myself Sharan Reddy. I do have 10 plus experience in healthcare integration world. Currently, I'm working for Henry Ford Health. Today, I would like to start with my topic as in building resilient healthcare mobility platforms for the engineering epic rideshare integration at a scale. And simply, it's saying that basically we have an epic EHR systems. I would like to integrate with rideshare platform with the integration for the patient. So this is about the topic. So I would like to explain here are the few agenda items that I would like to cover in this topic is that technical architecture overview, engineering challenges, and microservices implementation and security observability and machine learning ops in healthcare. So these are the agenda items I would like to cover in the topic. Now, beginning about the how this Epic integration platform works, like, and I'm gonna give an example how the real world example it will give a better explanation about in terms of that. So let me begin with the problem that affects millions of patients in the United States. One in five patients either misses or delays simply because they don't have a reliable transportation. Now imagine this is not just on a regular checkup. Think if any dialysis patient or if any patient, if a cancer patient attending a chemotherapy, even missing in a one appointment, that could be in a life threatening for the patient. So it may to have serious health consequences. Moreover, hospital visits and even shorten the life expectancy, and also it would create an additional burden to the patient on the like if on the insurance as well, because if the patient doesn't show at the insurance the hospital, that the provider gonna put as a no show, and that would even a charge also for the patient. So without attending to any kind of treatment or not seeing an appointment, either way the patient might be lost. So the thing is that the challenge is very clear here. We would like to tell how the solution is like healthcare isn't just about what happens inside the hospital. It is also about making sure patients can actually get there. Our vision is straightforward that we want to bridge Epic EHR record system to the hospital already used to manage appointments in the patient data with the everyday rideshare platform with Uber and Lyft. The goal for every patient reliable in complete and timely way to reach their care and to the hospital and get the better patient outcome. In terms of platform, the if you see about the numbers, the daily like 6.5 million daily patient record exchange, they processed securely across the systems, and 2400 plus health system connected through the platform. Moving to another topic here, how this entire Epic rideshare integration challenges, like how it is integrated. There are some core components that been involved in this Epic integration platform. So Epic Smart and Fire, which is like in a standard, it's Fire is a fast and resources, which is now a trend in healthcare basically, where you will get the patient access the data within using a REST API. Earlier, we used to have an HL7 version 2.x and 3.x. Now with the Fire, where it is in a set of data standard using a JSON with an XML content that can be used to exchange for this platform. In terms of an architecture, when you talk in terms of technical side, Epic Smart and Fire set standards like an grammar for healthcare basically. It would be like an communication language easily without it would be a doctor's patients systems all speaking different languages. Now rideshare API is like an Uber and Lyft weren't built for healthcare platforms, so they were designed for consumer convenience. So quick pickup is that estimated arrival time, but they don't have a built-in compliance the protection to sensitive medical data. So that is where there the integration layer comes here. This layer acts as a bridge basically. It's like a translator with a security guard combined. It makes sure the data flow correctly, quickly, and securely between Epic and the ride-share system platform like either Uber or other Lyft. And moving to the second agenda topic is core engineering challenges basically. So in the core engineering challenges, we have bidirectional API flow management system and fault tolerance implementation. So now let's talk about the core engineering challenges. The first, bidirectional API flow, which Epic needs a share an appointment detail and a patient context of the ride share information that needs to be single things like a driver location, estimated arrival, and a drop off confirmation. On the both sides, they need to be a constantly sync between Epic and the patient, and at the same time, the app also need to be aware. So the second, the fault tolerance implementation is that what if the lift goes down? Like the system needs to instantly switch to another provider, like in a Uber, or without any patient even noticing. It's like in a just in a GPS rerouting. You instantly, when a road is closed, automatically you will get in a reroute option. The estimated arrival is like 5 minutes, so you can choose this particular map and you go where the care must be also continue without any interruption. When lift goes down, automatically Uber picks up. So that kind of a platform that we need to switch based upon that. And there is a third that most important is that the HIPAA compliant data pipelines. So every single ride request involves more than 47 sensitive variables like a patient name, like an entire PHI, which comes as a patient name, appointment type, and pickup and address, notes, and about all the mobility needs. Each one must be an encrypted, logged, and auditable, and nothing can slip through the cracks. Basically, in terms of this EPUB compliance, these aren't abstract challenges; they are directly impact whether the patient makes it dialysis today or in a cancer treatment. So any difference can make a line between good health and serious complications. So this is why engineering isn't just about a clever code, it's about the patient lives depending upon the system that we design. So moving to the next topic is like overall how this entire platform works like in a core microservice architecture. There are like some of the core components like Epic integrations and transporter orchestrators and provider gateway and patient profile, compliance and age, and there are event bus, Kafka. We have in the Kafka, there's a queuing platform system basically for a Kafka real-time events where you will get a transportation request, state changes, appointment updates from Epic, driver locations and updates, and even the compliance related to the audit trails as well. And another component is a PostgreSQL for transactions where it gives a complete ride history and billing reconciliation data and compliance and documentation and configuration management. So reduce of performance like patient transportation profiles. Here the data to make this work reliable, the microservices and event driven approach. With the Kafka, we can stream events. The patient books when a driver updates their status, or it gives an instant lookup such as whether the patient needs a wheelchair access. That helps the patient basically, and this is like in a separation a powerful where instant one giant system trying to do everything. Each microservice is like in a specialized hospital wing, one wing for emergency care and another for lab test and another for surgery and another for radiology, oncology. Each has its own team and it operates on own services, but apart from that they are all connected by secure hallways. This design means each services can scale and independently suddenly for more patient need rides during a flu season. The ride matching services can scale up without slowing down everything else. So it's not just an elegant that the architecture of micro. It's always a board ensures that patients can depend on these rights and every time, no matter what it is. So moving to another agenda topic here is that Kubernetes orchestrations and SRE practices. So here we categorize as a four components like an multi-region deployment, auto scaling, and automated failover and canary deployments. So our system runs on multi-regions on AWS deployment. Think it we have a backup hospitals in different cities. If one goes offline and patients are automatically routed to another, so care continues without any delay. We also use a predictive auto scaling. This means we study historical clinic loads. For example, flu season brings more patients, so the system automatically scales a capacity in advance. For example, in the COVID, we might see this. If you have more number of patients, that's also you can take in a COVID real world example that auto scales if you have more patients affected with COVID-19, and that is one of the best example to explain for auto scaling. So not only flu season, then there is an active, meaning two or more systems run at the same time. Even if one fails and automatically another node picks up like continuously. If another node fails, so there would be another backup node. So when we roll out few new features, we don't push them to every one at once. We use canary deployments, and just like in a hospital might test a new procedure with a small group of patients, making it as a standard practice together. So these approaches like 99 point, whatever these approaches, like four approaches, which gives 99.9% as an uptime. But in healthcare, uptime isn't about convenience, it's about saving lives. Moving to another agenda topic, so security engineering and zero trust architecture. So in this also we cover like the four major components like data protection, authentication and authorization, and network security. So when dealing with the patient data, the security isn't an optional. So it's a foundation for a patient healthcare. When we use a zero trust security, which means that every request must prove itself no matter where it comes from. So, like checking every visitor at the hospital door, even their wear a staff badge or anything. So, no matter what endpoint that we are getting, so either internal or external application that is hitting the application. So we always in trust based, rotator based tokens encrypt all the data with AES 256 encryption for all the data transit. Enforce OAuth 2 and PKCE on the network side. We secured the traffic with TLS and web application firewalls. But beyond security, observability, it's just a critical. We need a visibility of both technical and clinical access. If the API slows down, it's an IT problem. But if dialysis right is late, that's a clinical problem. It could harm a patient. So our monitoring separates these signals so the right team responds quickly. So if we even measure a custom SLA metrics that ties timelines directly to medical schedule, because in one of the system performance is about just number on a board. It's about the patient getting a care what they need and on time. So I would like to move to another topic, machine learning ops with the challenges in healthcare transportation. This is the topic that we're going to cover. In this also there are some of the core components in order for this thing like data collection, feature engineering and model deployment and compliant deployment and continuous monitoring. So now as a boom of AI and machine learning also plays a role improving the healthcare mobility, our pipeline moves from data collection into a feature engineering, modern development and deployment, and finally monitoring. But healthcare brings a unique challenge. Patient data is often incomplete and transparency in critical, and clinicians need to understand why the AI system is made as a recommendation. Despite these challenges, the impact significant in our deployments. AI has helped to reduce the patient no-show by 42%. Here is a simple example. Suppose the system learns that Mr. John Doe often cancels the raids on Monday morning. AI can proactively schedule a backup for that ride and send a reminder, reducing risk miscare. So in healthcare mobility, every predictive step AI takes a sense of one more patient get there an appointment on time, leading to a better outcome. So if you see here the platform, what are the graph that you would see is the successful 10x graph spikes during the weather emergencies and processing 15 million transportation event in monthly and reduce 42% I was discussing in the previously. So moving to the design on the platform. So let me share the real case study on this platform, reliability metrics in engineering impacts. At a mid-sized hospital in Chicago, about 40% of dialysis patients are missing an appointment each month because of unreliability transport. That's the nearly half of the patient unable to get a life-saving treatment. We implemented this platform integrating with Epic scheduling directly with Lyft API. Patient needs like in a wheelchair, access for care notes we are mapped automatically into a ride request. During a Midwest storm in Chicago, so the system held a strong thanks to multi-region failover, even in harsh conditions as well. So the patients still got their own appointments, and the results were dramatic, and no-show has been dropped almost like 40%. If you calculate it with just 15% in 6 months, the patients reported higher satisfaction when we integrated this Epic Rate Share platform. Clinicians also received about 20 hours each month because they no longer had manually coordinated the transport, and also the insurance companies which are the what are the providers charge for the insurance for if you don't show as a no show, that may be also charged, right? So that also reduces a little bit dropped as well. So moving to another topic here, the key takeaways of the platform engineering. Here we have four components like design API, clinical workflows, and manage sensitive data across the systems and implement healthcare compliant in CI/CD pipeline, and also align monitoring with the clinical requirements as well. So for an engineer, there are like whatever the four topics, the big lessons here. First, API in healthcare must be designed around a patient care, not just an data exchange. Every call impacts that real lives. Second, appliance isn't it something you tag or later CI/CD pipelines must automate approvals and audits from the beginning. The third is that governance of sensitive data is critical. Every piece of a patient information must be a traceable end to end basically. And finally, the observability needs to be served on both IT and clinicians team. It's not enough to know if the system is fast. We need to know if the patient actually got their own appointment in time. So these four takeaways that shows that building of an healthcare means thinking beyond the code. It's about designing the system that protects, scale, and heal for this entire platform. So moving to another topic that I would like to end with the entire my topic. It's an end basically. I would like to put my closing statement about this epic integration platform with the Uber or Lyft or whatever. So We are not just solving a technology problem here, we are just addressing healthcare equity problem. Too many patients miss care because of transportation fail. For a platform engineers, the challenges is to embrace compliances and security and reliability, the design drivers, not blockers. This is a mindset where what the system makes like this possible. And here is a moral memorable point that I would like to leave in this entire presentation. So in healthcare, uptime isn't just a metric, it's a lifeline basically. And this system we build don't just move data or code, they move the patients, they keep the treatment on track, and they save the lives. And that's why this works matter. And thank you for giving this opportunity. I would like to close my presentation.